So today we're gonna talking about another very basic data structure. Okay, it's called linked list. Okay, so linked list is one of the basic data structure, right, in the programming, and it is a linear data structure. What's the meaning of linear data structure? Remember, we're talking about the list and array, right? Array is one type of linear data structure. Why we call linear? Because the value of this data structure, they are positioned one by one. Okay, it's just like a chain. Okay, in the order, in the sequence. Okay, so for example, for the array, every value is put in the continuous location, right, in the memory. Why we say continuous, right? Because they are, sitting next to each other. And the array has index to indicating the position of the value in the entire, right, array variable. Okay, so, and this is the array data structure. It is linear data structure. Okay, so linked list. Linked list is also an array linear data structure because it is a one-dimension chain, right? You can understand that it's a one-dimension chain. Okay, every item in this data structure, they are linking to each other. And the biggest difference between the array and the linked list is array has index. Okay, you can understand as the chain of bucket, but they are bounded with each other and it has an index 0, 1, 2, 3, 4. And the value is put into each index. Okay, but the linked list, okay, they may not continuous location in the memory, okay, but they're linking with each other using pointer, right? You see the point here, okay? Every item in the linked list, it has a value, okay? It has a value. So for example, the first one, the value is 2. And also it has a reference point, right? We can also call it next. Basically telling who is the next item. So the value 2, his next point or next reference is point to who? 3. Okay, so I know after 2, it's 3. After 3, it's 5. After 5, it's 7. Okay, they are not in the continuous location of the memory. They can store it in different places, but they have the reference pointer to link with each other. Okay, to link with each other. That is also called a single linked list. Okay, because there's always one next reference which is pointing to who is your next item. Okay, and for a given linked list or a chain, the first item we call it head, the last item we call it tail. That's easy to understand, right? Okay, so we have a head, we have a tail, and in every segment or every item element in the list, okay, they are linking with each other by using a pointer. By using a pointer, that we call is linked to the list. Any question? We good, right? Okay. Next one. So we said a linked list can be a list of different elements. Okay? And each element, like here, each element, this is element, element, element. Like for this linked list, there's the 4 elements, 4 items. For each element, we can call that list node, call that node. Okay? For each node, we have 2 different feeds. Okay? We have data, we have next. Data contains the value, okay, which is stored in the node. People ask you, okay, what's the value of this linked list node? We have a data, right? Here is 3. The 3 is the data. It is also the value of the entire node. And also the second feed of that node we call next. Next is the name, but it's just the reference to the next node on the list. Okay? So repeat again. In the linked chain, there are multiple elements. For each single element, it consists data and next. Okay, next is the reference to the next node on the list. Okay, if we take a look at this, okay, if you can understand it, this is a linked list, right? It has totally 4 elements. Okay, each element is called a node. For each node, it has data, it has next reference. Okay, the next reference, right, is pointing to who is my next node. Okay, so you can see, I mean, though the value for each node, right, in this example is the same, 3. Okay, but the next reference is pointing to the next node, right? The first one points to the second one, the second one points to the third one, the third one points to the fourth one. So that is consists the whole list. Okay, and the list is called linked list. Why we call that linked list? Because that's a reference point to the next one. Okay, so let's take a look at this again. A linked list is a collection of nodes. Okay, so a linked list can have multiple nodes, as many as you want, right? And the first node is called head of the list. The last node is called tail of the list. Okay, look at here. The first node, we also call that head. The value is 3. His pointer, his next pointer is pointing to the second node, whose value is 1. The second node, his next reference is pointing to the third node, whose value is 4. The next reference of the third node is pointing to the fourth node, whose value is 10. Okay, and actually, the fourth node is the last node. Okay, then you may ask me, if this is last node, then what is the next reference of this node pointing to? Okay, so by default, it's pointing to none, which means I'm the last. There's no one be my next. Okay, so we said the next reference of the last node is pointing to none. Okay? Do you guys have any question? Okay, if no more question, I'm going to ask you a question. Okay? Julian.
Yeah.
How many nodes do we have here in this list?
4.
Okay. Who is the last? Who is the tail?
Who is the what?
Who is the tail of the list?
10.
10. Okay. What is the next reference pointing to for the 10 nodes, right? The node of 10. We know the tail is 10, right? The 10 node, this node, the value is 10. I'm asking you, what is this? What is the next reference of this node pointing to? Julian.
None.
None. Very good. Okay. None. Which means nobody after me. I'm the last one. Okay. Jeffrey.
Yes.
What is the second node in the list?
The second node. The child.
What is the second node in the list? Are you listening to me, Jeffrey?
Oh, yeah, but I said it's a child.
No, that means you're not listening to me. Okay, I hope you listen to me carefully. Louis, what's the second node of the list? Louis, what's the second node of the list? I cannot hear you.
1.
1. Okay. And what the next reference pointing to? What's the next reference of node 1 pointing to?
4.
4. Good. Right? And who is pointing to node 1?
3.
3. Okay. So that's a proof you are listening to me. Okay. Jeffrey, I repeat again. Okay. The whole list here contains 4 nodes. Each node has 2 feeds. Okay. One is data, is the value of the node. The other is next reference, which means it's a pointer to the next node of him. Okay. So here, the head, the first node of the list is also called head. The last one is called tail. The first node, the head of this list is 3, node 3. Okay. And who is node 3 pointing to? Node 1. Right? That's the second node in the list. And the node 1 is pointing to node 4. Node 4 is pointing to node 10. Node 10 is pointing to who? None, because I'm the last. So it's pointing to none, nobody. Okay, Jeffrey, do you understand it right now?
Oh, yeah.
Okay.
All the nodes point to one another. And there's feet.
Okay, that's very important. Okay. Every element we call a node. Okay, every element in the list we call a node. Each node has 2 different feeds, right? It has the data, which contains the value of the whole node. The second feed is called next. It's a reference to the next node on the list. Okay, that's called node for a linked list. A linked list is a collection, right? It's a collection of nodes. They are linking to each other, right? By using his own what? next reference. Okay, so since we understand, right, what is the linked list? Now let's make a comparison between the array and the linked list, right? Because both of them we already started. So what's the difference? Right, again, the data structure in the programming, we have several basic data structure, okay? But they have different advantage and disadvantage. They have different, features, right? They have different functionalities. When which dictionary data structure we should use depends on the problem, depends on the scenario. That is how the algorithm or those computations testing you. They give you some like a practical problem in your life. And when you analyze those problems, the first things you have to decide is, hey, this problem, which data structure I should choose to solve my problem? Which data structure is the best describe this problem? Okay. So array and linked list. Let's take a look at the first line. Array is stored at contiguous memory location. We explained last time. Okay, memory is a storage, right? Where we put all those data. Okay, and we have a CPU. CPU is read data from the memory storage. Okay, and the memory storage is just like a storage box. Okay, and each box is representing a position in the memory. Okay, and I think it's easy to understand if all your stuff, right, put in the continuous location together, which means what? Which means faster the CPU can read them, because CPU understand they are put next to each other in the memory location. So I just need to know the position of the first value, right? And then I can continue reading the rest of the data for the whole array. Okay, so that is one of the advantage of array because of the way how it is stored in the memory. Okay, so it's very fast to access. Okay, so the first feature of array is they are stored at contiguous memory location. And look at the linked list. Linked list is not stored at a contiguous location. What does it mean? It means in the memory storage box, right? Every element or value of the linked list can be stored in different places. Okay, so then the question is, if my CPU read the first value of your linked list, how do I know where is my second value? It's different from array because array, they are contiguous memory location, right? So I know, oh, if the first value is located in memory box 100, then the second value is located where? 101. The third value is located in 102, right? So CPU understand where he can looking for the next value, but linked lists, they are not stored contiguously. But what we explained, linked lists, though they are not stored in a contiguous location, but they have a next reference. Next reference what? It's used to pointing to where is my next value, right? So when the CPU read the linked list, okay, I know the first value is located here. So how the CPU know the next value? it had the reference, right? So pointing to the next value location. So CPU using the reference to find the next value location and read that. How about third one? Oh, third also have a next reference pointing to the third node location. So CPU is able to read the whole list by using the reference point. Clear? So let me ask you, which one is faster? For the CPU, for the machine, right, read the whole array against read the whole linked list. Which one is faster? Victor, think about that. Which one is faster? Reading array faster or reading a linked list is faster? Victor.
Reading a list.
You think reading a list is faster?
What was the other one?
The first one is array. Okay. The second one is the linked list. Which one will be read fast?
In this?
All right, thank you. Which one? Array or list?
A list.
Okay. Jeffrey, what do you think?
Oh yeah, it's also linked list. The size is dynamic, and you can like it's just faster to use.
I don't know what you guys listen to. Am I really not explaining very clearly? Aston, what do you think?
All right.
Array is faster, right? Think about that, right? You visit your friends, right? You visit several friends who wanted to play together, okay? Array means all your friends are living next to each other, right? You go to the first friend, then you go to the next friend, then you go to the next friend. They're living next to each other, okay? That's array. The linked list means what? All the friends you're looking for that live in different places, okay? So you go to the first friend's place, and the friends tell you, hey, next friend is living 10 miles away from my house. Okay, let's go to his home. And then you go to the second friend home, and the second friend tell you, hey, the third friend is living 5 miles from my house. And you go to the third friend. So which way do you think, right, is faster to get all your friends? Victor and Jeffrey, now do you understand the difference?
Oh yeah, so array is faster.
Yes.
Okay. If you don't understand, just let me know. I can explain again. Okay. Louis, you understand that, right? Okay. So again, right, each data structure has different pros and cons. Okay. There's no like a statement say which one is always best. Okay, remember that. Okay. There's only like a statement that which one is most suitable. Okay. So now go to the second, right? Second point of the two different data structures. Okay. For the array, the size is fixed. Why do I say so? Because the array will be stored in a contiguous memory location. So which means when you create array, the machine or the CPU will decide, hey, you're going to create array of size 10. So then CPU will go to the memory location, right? And to give you a size of 10 you know, give you 10 memory boxes, right, to you. So then you can use using those contiguous memory location. Okay, whenever there's other new data write into the memory, it will put from the 11th box. It will not touching the 10 boxes. Because why? Because this 10 memory location is already reserved for this array. Okay. So with that, we said it's fixed size. Because you can definitely give him a dynamic size. Why? I cannot leave the whole memory for you array, right? How about other data? When the other data using memory, I need to give the location to store the data. So I can only do, you give me the size, I reserve the location. Okay, you understand that? When we create an array, the size has to be tell first. I want to create an array of totally like size of 10. Okay, so the CPU can give you 10 memory box, but they are contiguous, right? Okay. But maybe you can ask me, hey, then why I have append or like add a new function, right, to the array? It does. Arrays allow you to add a new one, but what happened in the memory is, suppose you at the beginning when you create the array, right, it give you size of 10, okay, and then you try to add the 11th value. What is the machine gonna do? Okay, what it's gonna do is it's gonna find a new place of 11 box. Okay, and then copy the value, copy each value from the older 10 box, right, to the new 11 box, plus the new added value. So it is still contiguous memory location for this array, but the difference is what? The whole memory locations have to be changed, right? Okay, so that's the difference. Okay, so the size of an array is fixed. And the linked list is dynamic. Why is dynamic? It's easy to understand because they are stored in different locations. So at which location, it doesn't matter. When the value comes, memory said, hey, I'll give you the next available location. You put it here, okay? Right? But whatever the next reference of the previous node gonna point into the new memory location to point that. That's the reason why we said the linked list is a dynamic size, because you can add a new node anytime dynamically without changing the existing node, without changing the location of those existing nodes. Okay, so this is very important. I don't know if you guys really understand what I'm explaining. Connor, you understand what I explained?
Wait, what?
I'm asking you, I'm explaining why the size of the array is fixed, and meanwhile linked list is a dynamic.
Yeah.
You understand what I'm trying to say, right?
Yeah.
Okay. Aston, you understand that? Okay. Okay. So the third item is elements in position with index. Okay, that's easy to understand, right? Every array, right, for every, how to say, position, right, in the array, we have an index, 0, 1, 2, 3. Why we can use an index? Because they are contiguous. Okay? So for the linked list, they are using pointers. Okay? They cannot use the index because they are not located, physically located with each other in the memory. That's the reason why they have to using a reference pointer. Okay, so reference pointer allowed you pointing to next node wherever he located. I always had the pointer. Okay, I can find him no matter where he is located. That's the biggest difference, right? And because of the contiguous location, storage, and the index, that's the reason why we said array is fast access by using what? Index. You remember how we access a value from the array? We're using index. Okay, we're using index. And relatively, linked list is a slow access because why? We have to find from the head who is my next, who is my next, who is my next, and find out whatever the value we're looking for. Okay, so array fast access, linked list is a slow access. Okay, and also the last item, slow insertion and deletion. Okay, why we say that? Because in order to keep the continuous memory location, right, just as I explained, you have 10 sites, or you try to add 11s. Okay, you have to find another 11 contiguous memory location and copy over, right? All those copy stuff or copy action is overhead operations. So that's why it is slow. Deletion also, you try to delete something, whatever the rest of the value has to be swift ahead. Okay, I'm gonna explain to you in the next slide. For the linked list, it's relatively fast insertion and deletion. Why? Think about that, right? I try to add a new item into the list. Okay, I only need to know the position where I should insert the item. And then what? Break the existing reference and make the previous node pointing to the new node and make the next reference of the new node pointing to the original next node. Okay, so don't worry, right? I'm gonna explain to you in the next slides. Look at this one. Inserting in array and the inserting in array. Suppose this is your array. Okay, this is your array. Julian, what's the size of this array?
4.
The size is 5. Okay, because as you can see, it has 5 locations. 1, 2, 3, 4, 5. Right? 5 box is there. Okay, the size is 5. But again, there's only 4 values, right, in the array. Okay, starting from 0, 1, 2, 3 index. So now, if I wanted to insert a new value 3, okay, I'm gonna show you how the memory gonna do that. What actually the memory gonna doing is, first of all, it will find out the place where the 3 should be inserted. Okay, it said, oh, the 3 should be inserted between value 2 and value 4, right? So now, what I should do? There's no location. There's no like extra space between value 2 and value 4, right? What should I do? Oh, I found that there's extra space at the end of the array, right? So what the memory is doing is it's gonna moving those values which is after value 3, shift back. First, he's going to shift value 5, and then he's going to shift value 4. Oh, now this position is empty now. It's good for me to insert value 3. So, though the operation is only one, right? Which is insert the value 3. But underlying or whatever the operation in the background, including moving value 5, moving value 4, and insert value 3. Okay? And if your array is very big, think about it, if you have array of 100 values, and now you said, let me try to add a value at the third position. So which means what? Which means you almost gonna move like a 98 value first before you are able to insert the new value at the third position. Okay, so that is what actually happened when you do the insertion into array. Now let's take a look at the linked list. Linked list, okay, they are referenced to the next by using a next pointer. So here, Jeffrey, how many nodes do we have here in this linked list? Jeffrey?
Yeah, you have 3 nodes.
Okay. Who is tail? Who is head?
Who is what?
Who is tail? Who is head?
Oh, tail and head.
Uh-huh.
So the value 1 is the head and value 4 is the tail.
Okay, very good. So now let's take a look at. This is a linked list has 3 values or 3 nodes. Now I wanted to insert a new node or new value called 3, okay, which is supposed to insert between 2 and 4, right? So what is actually happening is, first of all, you're gonna break the reference between value 2 and value 4, and you're gonna create the value 3, and it will what? Change the next reference of value 2 pointing to value 3, and the last step is change the next reference of value 3 to value 4. Okay, so this set of operation will always be the same no matter how big the list it is. Think about that, right? If you have a list of 100 items, will there be any difference? No, because the only nodes I need to update is value 2, it's only value 2 and value 3. Think about it. Even value 4, do I change anything for value 4? No. Right? I only change the next reference of value 2, right? And create the value 3. That's it. I don't care how many lists, right, or how many nodes, right, after me, because I just need to change one reference, right? And it's actually 2 references, right? I change the reference of my previous node, and also I set my next reference to the original next node. Louis, do you get that?
Uh-huh.
Do you understand this?
But why did a 3 suddenly pop up?
Sorry, what's your question?
Green. Why is the 3 green?
Oh, why the 3 is green? I just want to highlight it and let you know this is a new node. There's no difference, okay? Okay. Victor, do you understand what I'm talking about the difference between the array and the linked list? How these two different data structure insert new node, new
Yes.
value? Okay. Summarize again. Why we said array is slow insertion, right? Go back here. Array is fast access, fast read. Okay. Why? We have index. They are contingents located with each other. So it's fast access, right? But also because of the contingent location, right? It is slow update, which means slow insertion and slow deletion, because I have to maintain the contingent index. That's the reason why if array insert a new one, he has to make sure that adjust the rest of the value in the array, right? And if unluckily you try to insert a new value into a full array, right? There's no space in the array anymore, but you try to add or append new value. What X doing is gonna find new places which can suitable the new, all the values and copy everything over. Okay. But the linked list is slow read. Why? Because I always have to find from the first one. Oh, and my next one, until I find the value I need looking for. It's very slow access, slow read, but it is fast update. Because no matter you insert a new node or you remove existing node, what you need to do is you just need to update. Okay, update the reference of two nodes. Clear? Then I have a very interesting question. What happened if we try to delete something? What happens if I try to delete a node from a linked list? Aston,
Can you repeat the question?
my question, look at my screen, okay? From the button, excuse me, from the button, okay, I have a list of 4 nodes, 1, 2, 3, 4, right? Now I wanted to delete node 3. What are you gonna do? What actually, the backend or machine gonna do?
So
Can I speak louder? I cannot hear you
value
clearly.
4 replace value 3.
No, can I speak louder?
Value 4 would replace value 3 spot.
Value 4 will replace value. What do you mean replace? They are
Like
stored in different location, okay? Again, they are stored in different location. They are referenced to each other using pointer. Okay?
So if you get rid of value 3,
Yeah,
value 2 would point to value 4, right?
correct. Right? So if you look, reverse it, okay? What happened, if you look at from the button, I have a list 1, 2, 3, 4. I want to remove the value 3. What do you first do? Oh, I need to first break the reference from value 3 to value 4, and also break, right, the reference from value 2 to value 3. And then what? Make my next reference for value 2 pointing to value 4. That's it, right? So which means I already kicked out the value 3 from the entire linked list, because my value 2 now is pointing to value 4. No one is pointing to value 3 now. Value 3 is kicked out. That is how we do the deletion from a linked list. Okay? Okay. So talking about, right, those much. Let's try to see how we really implement, okay, a linked list in Python. Different from array in Python, right? We already have built-in array, but not for the linked list. We have to create by ourselves. Okay, so now we said a linked list consists of node, right? So let's take a look at the node class. Here we're in class, right? We have learned class before. Okay, so node, Jeffrey, how many fees do we have in a node?
Wait, could you repeat that?
How many feeds do we have in a node?
Let me see. I'm guessing 2.
2. What are they?
Self and data.
Self is not a feed. Okay, self is the whole class.
Oh, data and next.
Good. Look at here. We try to create a node class. Okay. What is the init function used for? Julian, do you still remember what is the underscore init function underscore used for?
For a class.
For class, yeah, it's called constructor function for class. This will be called when you create a new object of the class, right? You remember the relationship between object and a class. I have what? I have a class of car, okay? Car class, right? I can create as many as objects from the car class. Okay, I can create as many as objects from the class because each object is a detailed implementation of this class prototype. I have a class called car, but I can have an object say Tesla. I can have an object of BMW, right? They are the detailed implementation of the car. Okay, but car only have one car class. It's in here, node. Node is only a one class node, but again, I can create multiple or as many as node objects. Why? Because I can have different data and I can have different node for each node objects. That's a different class object. Here, I create a node class, and in the init function, it's parsing data. Okay, so when you create a node class, you need parsing data, the value of this node. Okay, so then it will create I have a given value of data, and I have next reference node. Why the next is none? Because you only create a node. You didn't put the node into any linked list. That's the reason why the next reference is going to be initialized as value none. Okay, clear? So now let's take a look at this. Okay, what I'm going to do is I'm going to do that in the graphical.it. You guys better to listen carefully, okay? Because that is what exactly what I want you created in your assignment, okay? Try to add a new one. We can call that linked list. Okay. So I'm gonna have a class node. So how we create a class? We're using keyword class, right? And then we're gonna have a init constructor function. Okay, the first parameter is always self. That's the same for all the function inside a class. Self. Okay. Now I want to put a data as my parameter. Okay. So self dot data equals data, and self dot next equals to none. Okay, that's it. I have finished the creation of a node class. Okay, I have a definition for class. Now I want to use that. How am I going to use that? Node 1 equals, right? Node. What I should parsing? I need to parsing data. Okay, I can put 1 as my value, as my data. Okay, and I can create node 2. That means I create the different objects of the class node. Okay, how many nodes do I have here? I have 2 nodes, right? If I do a print node 1, what we found? Hey, this node 1 is from node class object at blah 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 blah. Anybody know what is this? Connor, what is this? Do you know?
Not sure. It might be some encoded version of the location.
Yes, that's a encoded location in the memory. Okay, it's the location in the memory. It's not human readable, but you just know, right? Because every time when we create object, create a value, it's gonna allocate a specific location in the memory for you to store the data. Okay. Same thing. If you print node 2, I run this, right? Do you see the value? This value is different because they are created in random, right, location. Okay, so then you print out the object, right? But we don't want it object. We want the details like data or value, right? So suppose I put print node 1.data. I want to see, hey, what's the value of my node 1, right? So I run this, it's gonna print out 1. Because why? Because I'm parsing 1. 1 is the data. It is assigned to feed data. And then you may say, hey, what about the node 1.next, right? I have a feed called next, right? If I run this, oh, it's pointing to none. That's class node. Okay. Once we have a node, linked list is a collection of nodes. So how can we create a linked list? Okay, where is it? It only have a head feed, and the head feed is pointing to whom? Pointing to, I mean, right now it's none, right? But ideally it should be pointing to the first node. Okay, so this class is actually create an empty linked list. Okay, once you add the first node into the list, the header will be updated to the first node. Okay, now let me define the linked list class first. Okay, I have a class called linked list, and then I have a def init, and I have self, right? Though I don't have any parameter, but I know I have a feed called head. At the beginning, it's empty, so the head pointing to none. Okay, I have class of node. I have a class of linked list. What's next? I'm going to use it to create a list. Okay, look at here. Create linked list and 3 nodes. Okay, let's do like that. Okay, I'm going to create node 1 equals to node, right? 1. Have a node 2 equals to node 2. Have a node 3 equals to node 3. Okay, you understand, right? I create 3 objects of class node, right? Each one have different data, different value, 1, 2, 3. Okay, now I'm gonna add those nodes into the list. How am I gonna add that? Okay, so I have my linked list equals to linked list. Right? I first create an object of class linked list. If you print out, what do you get? You just know, oh, this is the object of the linked list class and the memory location. But do we have any value for that? If you press head, it's none. Oh, the list is empty, but there's no head node. Okay, what happened if I said my linked list head is what? Equals to the node 1. What I do? I inserted the first node into the list. And when we said you try to insert a node into the list, there must be a change of what? Change of the reference pointer. Right here, what we're actually doing is we change the head pointer to the first node. Okay, I run this. Oh, I see that, right? If I said header dot data is bring me 1. Why is 1? Because the header is pointing to node 1 now, right? Here I'm pointing to node 1 data. Okay, so then we said, if I have the first value, first node, so what I'm gonna do is I'm gonna say, hey, now let me set node 1 dot next pointing to node 2, and node 2 dot next pointing to who? Node 3. Okay, I just put every node into the list, right? And I just need to know the head of the list. Then I'm able to access all the nodes, right? That's it. I have created a list and insert 3 nodes into the list. Okay, so go to my slides. Set pointer for the first and second nodes. Okay, here, same thing, right? Create the list and set the header of the list to the first node, and then create second and third nodes, right? Okay, let's look at this diagram. 3 nodes has been created. We have reference to these 3 blocks at head, second, and third. Okay, the head will be pointing to what? The first node. Okay, and at the beginning, every node is not linked to each other because the next reference is all pointing to none. Right? They only just create, but they're not linked to each other. Okay, so now we try to link the first node with the second node. Okay, so we're using link head next equals to second, basically setting the value for the next reference to the location of the second one, right? Okay, so after this, what's gonna happen? After this, the first node is linking to the second, and I try to set second dot next equals to third. Link second node with the third node. Now the next of the second node refers to third. So all 3 nodes are linked. If you look at this diagram, we know the first node is 1, and his next pointing to the node 2, and then the next of node 2 is pointing to node 3. That's it. You create a list. You put a node and link them each other. Any question? Aston, do you understand that?
Yeah, I get it.
Okay. Louis, do you understand it?
Yeah.
Jeffrey?
Yes, I do.
Okay. Victor, do you understand it?
Yes, I do.
Okay. Okay. So let me see. Then what is this? Okay, this is about travel so of the whole list. Okay, so let me go back to my code. We know if I have a list, okay, if I have my list equals to 1, 2, 3, 4. How do I loop the whole list? Easy, right? For x in my list, print x and 1. You guys ask me what is the enemy, right? And means the append, right? After print each character. Okay, so if I doing like that, let me just now it should be pop, right? Okay, I print out every value in the list. Then you may ask me, can I print out the same for a linked list? Can we use in for loop? No like. Okay, so if you look at the slides, what we here basically doing is the functions print the contents of linked list starting from head. Because for each linked list, you only know head. Okay, we don't have index. We only know the first node. Okay, so if you look at the code here, yes, I try to do a while loop. Why do we need to do while loop, not for loop? Julian, can I make a guess? Why do we need a while loop instead of for loop? Julian?
Because it's not a variable.
No. What do you mean it's not variable? Which one is not variable? When we're using for loop, you first need to know what's the total size. Am I correct? Right? For I in the range 1 to 10. I know that's total from, I know what's the total scope, right? From 1 to 10. That's the reason why I can use in for. And similarly, for X in the list, why can you use that? Because the list is a fixed size. I know the scope. That's the reason why I can use in for. While it's used because I don't know when should I end. I only can put a condition, when should I end, right? While condition to the loop. Same thing here. The linked list is a dynamic size. I don't know when, how big, how long it can be. I have to loop till I meet my tail node. That's the reason why I have to use while to loop the whole linked list. Okay, so look at the code. What I do is first, okay, I create a temp variable to hold the first node, right? Or to hold the head. Okay, the while temp means is it existing or not? Is it none or not? Right? If it's not none, fine. I print out what? Print out the data. And what I need to do, very important, I update the value of the temp to be the next node. Okay, I update the temp variable to be my next node. And I do it again. Every time print, okay, I point to the next one. I point to the next one. Look at this slide. I explained to you step by step how we do the looping here. Given a head, so given a head node of the linked list, how is actually looping the entire list? Suppose this is the list, okay? Right? And I have create a temp variable. Okay, this temp variable, you can understand the loop variable because I need to hold every node when we're looping the list. So now, the first step, the temp gonna point into the first node. Okay, just like this one, temp equals to self head. Okay, so for the first loop, temp equals to the first node, right? And it will be print out the data one. Do you have any questions regarding this? The first round, temp equals to the head, right? Because we set head equals to the first node. So temp pointing to first node. Temp is, okay, temp is first node. That's the reason why I said a temp.data, I print out data one. Okay, and then what happened? I set the temp equals to temp.next. Which one's temp? Data one's temp. This first node is temp. So I make myself equals to the next. Who is next? Data two. So what exactly happened is I change the value of the temp, make it become the second node. That is how temp equals to temp.next doing. Are we following? Aston.
Yeah.
Okay. So then it comes back to the while loop again. A while loop, what is the while loop checking? Hey, if the temp is none, it's not none, right? If it's not none, it will go inside again. And right now, temp is the second node. So it's print out second node data, right? Second node data going to print out data two. And again, what happened is temp equals temp.next. What is the value for temp right now? Second node. Okay, so update temp pointing to second node next, which means it will be node 3 now. Okay, then it's go back to the loop again. You check, hey, if the temp currently is not null. Yes, it is not null. So I go to the while loop again, print out data 3. Similarly, it will I'm gonna update be the next, be node 4. Right? Node 4. So it's not null. So print out node 4. And very important. Now I need update data to be the node 4 dot next. Temp equals null. I mean to specifically, you know what? I should change it to be null. Okay. Okay, let's try it again. First, temp equals the first node. Okay. It's gonna print out data 1, the value of the first node. Second, it's gonna update to my next, which is second node, right? Print the second node value, data 2. Okay, update to my next, third node, testing, print out the third node value, data 3. Hit that back to the fourth node, print out the value of the fourth node, data 4. After that, they're gonna update to the next of node 4. What's the value of node 4? Next, which is none. And when temp is none, while none is false. So it will not print and do the update again. That's the end of the whole loop. Okay, so look at this slice again. First, set the temp equal cat. While temp print value, update the temp to my next. Until what? Until the last node. Because the last node's next is none. So when temp equals to none, the while condition will be false. The while gonna complete it. That's the way how we loop a linked list. Any more question? Okay, I'm assuming you guys are clear, right? Okay. I think that's it. Okay, I will not continue because it's almost time, and we do have some items or some like more things I want to explain. I can quickly show you guys, right? We're gonna talking about exactly how we're gonna, writing code to do the insertion and the deletion, right, inside a list. Okay, insertion m no item into a linked list, right, and then removing m item from a linked list. That'll be a little bit more like complicated, so I wanted to cover next time. And also we're going to talk about double linked list. Okay, double linked list, circular linked list. Okay, that's it. Are we clear? Okay, so, and the assignment of this class, I can ask you to create your own Python node, Python linked list, and create objects of the nodes and insert into the linked list, and again to travel or to loop your linked list. So I already give you the codes. Okay, if you don't know how to do that, okay, check my video. Okay, check my video again. And of course, I also give you a static web pages, right? There will be completed information about the Python linked list. Okay, you can do refer to the page by itself. Okay, okay, that's it. If no more questions, thank you everyone for today's participating in the class. Okay, enjoy the rest of the weekend.
Thank you. Good night.
Thank you. Good night. Bye bye.